Hello, everyone. Thank you for inviting me to talk at the CTO Leads meeting today. Today's talk, like you said, is entitled AI for Continuous Integration, which is a project that we've been working on in the AICOE, specifically in the AIOps group. And the subtitle here is Bootstrapping an AIOps Community, which I will talk a little bit more about throughout the talk. For those of you who don't know who I am, my name is Michael Clifford, and I'm a data scientist in the AICOE on the AIOps group, working with Marcel. So what do I want to talk about today, right? So the first thing is, what is this project? Like, what is it about from a high level? What are some of the motivations behind this project? Like, why are we doing it? Since there's somewhat of a tiered motivations, I think. Then I'll get a little bit into some of the details of the project. And then I'm assuming there will be enough time to do a quick demo at the end. So, right, what is the AI for Continuous Integration project? Like, in its most general sense, it's aimed at developing AI tools for developers by leveraging the data that's been made openly available by both OpenShift and Kubernetes CI platforms to foster a community around AIOps. So this project kind of consists of a number of different things, right? So firstly, it's an open source project that's been developed almost entirely by a team of data scientists using only like their Jupyter notebooks, and doing this on the Operate First environment with Open Data Hub, and supported by some of the Thoth tooling, which are all other projects that have been developed by the AICOE. This project also consists of both data engineering and machine learning components, right? So we've defined some specific KPIs about CI that we want to measure. We've developed like pipelines to collect this data and calculate these metrics from multiple disparate data sources that are relevant to CI, and like stored them in remote storage for later use, both as like for visualization, as well as like downstream machine learning tasks. Like I said, we've also defined and started to develop a number of these machine learning tasks in addition to just collecting this data. And we've also produced a lot of documentation, code, and issue templates, as well as like video walkthroughs for almost every notebook and piece of code that we've done to make like onboarding and contributing to this project like ideally as easy as possible. And if you're interested beyond this talk, all this content, right, can be found on the Operate First website, which I hope everyone is aware of, in our GitHub repo. It's also, you could even go ahead and like deploy the project directly from the Operate First Jupyter Hub instance and play around with like a live instance of the code right away. So why are we doing this project? So I've already hinted at that it kind of does more than one thing, right? So the first thing that we think about here is trying to kind of bootstrap an AIOps community. But you might be asking yourself, right, like, why does that need to happen? Or why does something like that not exist already? And it really comes down to this idea that the wider project of AIOps in general, not just like specifically at Red Hat, really has a data problem, right? Like, there's no MNIST for AIOps. There's no golden, reliable, publicly accessible data set that everyone can use to compare and improve models, right? Which is something that we really need to kind of push the community forward. There's no canonical data set. There's no canonical data set, and that's really due to a number of reasons. But it's mainly because, right, the data required to do AIOps is often like internal infrastructure data, which can be difficult to open source because it might have some critical information that you wouldn't want to release. So it's not that there's like no interest in these problems or in this wider project of AIOps, but it's that the data required to do it really like isn't readily available or accessible. So this is one of the main like problems, I think, where we were trying to overcome here by making the CI data that's available by the OpenShift project really like more accessible and try to fill this data gap. The other thing that is important to us as Red Hatters and data scientists on the AIOps teams that we actually want to like develop some of this real AIOps tooling, right? Some real machine learning project that can support operations. And two great targets for this, right, are both Kubernetes and OpenShift projects. And since they've, luckily for us, like made a lot of their CI data actually public, and I think like CI is absolutely within like the wheelhouse of AI ops, these platforms really make a lot of sense for us to focus our efforts on developing tools for. The other kind of tertiary motivation here with I think everything we're doing in the AI ops group is you want to like prove out that the MOC operate first open data hub instance we are running is working and useful. So we are like working on this project. As we're working on this project, we're actually generating real data science workloads, doing data processing, running notebooks, developing automated pipelines, like interacting with remote storage and doing all the cool stuff to support the other ongoing efforts in the AI COE. So those are like kind of the three, I'd say by maybe order of importance, motivations for this project. So again, we're really trying to get that AIOps community off the ground by making data readily available for developing AIOps tooling for OpenShift and Kubernetes with Data Hub on MOC with Operate First, and to also like help refine some of these best practices for cloud native data science development. Cool. So how exactly are we doing this? Like, what is it that the project actually consists of? And again, here I just want to kind of reiterate briefly that like the specific machine learning tasks themselves are slightly secondary. So it's not necessarily about developing a single machine learning tool, but setting the groundwork for many of these tools to be developed. So the first thing that we did, and the kind of the main work we've completed to date, has really been around like the data engineering steps. So that's simply been like identifying the data that we have available to us, collecting it, processing it, and then developing these pipelines to like automatically collect that data. And initially, we had to kind of, us data scientists were not CI experts. So the first thing we had to do was define some KPIs and metrics. And again, kind of why would we do this, right? The first step for any good kind of scientific approach is simply to measure the current state of this like phenomenon in question. So, right, say that we just started taking GitHub issue metadata and used some NLP tooling to start auto labeling the data. Like, do we know if the results are good? Do we know if they're bad? Do we know if it's improved the development process in any way? There's no real way of doing that without measuring the state of the CI process first. So, like I said, the first thing we did was define these key performance indicators of the CI platform. And yeah, the step was simply to, like I said, measure the current state of the platform based on all of the open source signals that are available to us or anyone else. And as we move forward with this, we are able to we could create a metrics dashboard for developers of OpenShift. We can also quantify, more importantly, like the impacts. So as we develop the community develops new tooling, and we can see how the KPIs are actually affected and prove that the tools that we're developing actually are beneficial. The other part is about like providing really easy access to the data. So we've developed everything so far, like I said, in notebooks that are really well documented. They contain markdown and data visualization in addition to the code that actually does the work. We have video demos for almost all the notebooks. The entire repo, like I mentioned earlier, has been packaged as an image that can be deployed through the Jupyter Lab UI on Operate First. So it's really easy. Like somebody could just go deploy it, play around with it, and interact with it as they see fit today. And by making the data really easy to access, we're trying to kind of like lower that barrier to contributions, right? So this means good documentation, as well as we have templates for the notebooks and the issues. that contain a lot of information about all of like the conventions that we use in the project, again, to just make it as easy as possible to contribute. We have also developed these automated workflows using both Elira and KF pipelines that are like composed solely of notebooks to generate our applications. So what kind of things are we actually measuring, right? Like what kind of things do you want to keep track of? So what you see here is not really fully an exhaustive list, and it actually continues to be updated. But right now, we're collecting data about everything you see here. So pass rate of tests, percent of flakes that occur, percent of failing tests, um, average test time, mean time to fix, all of these interesting metrics that can help us kind of generate a baseline for what is a standard operating behavior of a CI platform. I also want to be really clear that the data is collected in a way so that it can be like viewed from multiple different perspectives, right? So this image you see here, like the overall platform pass rate, which might be interested to some people, but you could also just look at like a particular job's pass rate or a specific test or some subset of tests that are interesting to you. So it's very flexible to slice the data in a way that is meaningful to the particular viewer. And these are all really metrics currently about like tests and builds and how their performance kind of evolves over time. So yeah, so these are the types of things that we're looking at to get a baseline to describe the CI process. But in addition to that, there's also some kind of tertiary data sets that we're including in this analysis. So like what are the actual data sets that we are working with to get this information? So this project started a few months ago around the test grid data set or the test grid kind of application. And I'm not sure how many people here are familiar with test grid, but it's an open source project started by Google that provides a really high level signal of how your CI jobs are performing over time. And the result is like a 2D graph that has test names as rows and builds as columns. And each thing has a value of like pass, fail, flake, timeout, or a number of different ways to categorize the results of the specific test. And this is the first open source data set that we started to work with. But like I said, it's really high level signal and it doesn't tell you everything. So then kind of we asked ourselves, right, if we're data scientists and we're trying to model this underlying phenomenon that is the CI process, what else would we need to look at? Like, say, for example, if our ultimate goal is to create like an automated root cause analysis tool, like what else makes up the CI process? So we're also looking at like PR data, right? So the code changes that need to be taken into account, both the diffs as well as like the developers' discussions and other metadata. And then once that PR is pushed or becomes part of like a periodic testing job, Prow actually goes ahead and runs the tests. And as it's doing this, it's generating a bunch of logs that describe like what happens when you actually run this code. So we want to be looking at that as well. And then Prow is also itself running somewhere. So there's also the telemetry data that describes what's actually going on in like the pods and cluster that's running these tests. And then also we have like the Bugzillas, which hopefully kind of capture the root cause of some issue after humans have triaged these issues. And then again, we have the test grid data, like I mentioned. So like taking this all together really gives us a fuller picture of the CI process, and we can start to think about some interesting things that we want to actually analyze. So like I said, we have these 5 different data sets, and for each data source mentioned, we have done some EDA for it, like exploratory data analysis. That's fairly in-depth, and we have like a 5 to 10 minute video for each one that goes through it. So I'm not going to go through everything here, but just to give you all kind of a quick example of the kinds of things that we're looking at. So for example, the telemetry data here, we can see that there's a time series for this particular metric as it kind of fluctuates over these short-lived clusters as it's running some tests. We can see the prow logs and label them based on whether they were a successful or a failed build. And clearly we can see in this image here that there's some structure to the data worth investigating. And I'll talk about a little about this a little bit later, but we actually have a project going on using unsupervised learning techniques to identify the different failure types based on this kind of data representation. We have the test grid data, where based on some kind of high-level statistical feature engineering of the different tests over time, we can cluster them and again see some structure in the data that's worth investigating. We also have GitHub data, where we can take some like pairwise features of the PR metadata to determine if there's any correlation between these features, and ultimately use that to do some predictive analysis of PR submissions. And we also have the Bugzilla data, where this particular graph is just showing the distribution of bugs based on the component of OpenShift that they're related to. So I know these plots are all pretty small and probably hard for you all to see, but just to let you know, like each data set, there's a full notebook going through all of these details that is open source and everyone has access to. The next kind of thing that we'd like to start looking at for this project would actually be doing like cross comparisons of these data sets. Like, for example, like which prow logs are associated with spikes in the telemetry data, and how can we find the corresponding Bugzilla to like ensure once a failure is identified, it doesn't have to be troubleshot again. Cool, but then yeah, how are we actually collecting this data, and how are we actually doing this work that I've been going over? So with the Operate First and Open Data Hub instance we have available to us, we have Jupyter Lab, Elira, Kubeflow, and KF pipelines, which are 4 tools that kind of work together to make this work much easier than it's been in the past. So Jupyter Lab, I'm not sure how many people here are familiar with it, but it's basically like the latest incarnation of the Jupyter notebook environment. It just has a quite nicer UI and a better set of features and extensions. And I would kind of deem this the primary and preferred development environment for data scientists. So this is where we're doing like 99%, if not 100, of our work. And then Elira is an extension for Jupyter Lab that actually lets us define pipelines with a really nice drag and drop interface so that we don't have to actually write any YAML files ourselves. It like generates them for us. And then these YAML files are consumed by KF pipelines and deploy and run our workflows on OpenShift for us. So this way we're essentially able to kind of like prototype data science, machine learning applications without ever leaving our like preferred Jupyter Hub, Jupyter Lab development environment. There are like a few conventions that need to be followed in our notebooks to make sure that we can run it as a pipeline this way. But like I mentioned earlier, we have some of these templates and documentation that should make it as easy as possible for new contributors. Cool. So right, that's the kind of the big data engineering piece. We wanted to measure some KPIs about the CI process. We've come up with a way to write notebooks in this like modular fashion such that we can pull the data, calculate metrics of interest, and then push it to Ceph automatically to be used later either by a visualization tool or a machine learning application. So cool. Now that we've kind of laid the groundwork for all of this, right? What's next, right? What do we want to do with this ultimately? So what we want to do is take on some real interesting problems, these machine learning tasks. And there's actually a lot of them. We've defined a kind of process by which people can submit ML request issues on our repo, and this is how we kind of collect and decide on the different ideas that we want to pursue. And the kind of things that we're working on right now. So I guess there's about 4 machine learning projects that are like in flight. The first thing that we're looking at is test grid failure type classification. So this is a project that we started a little while ago, and this was inspired by this like annotated image that we have here, where we have 4 different failure types that can be identified based on the unique failure patterns on the grid. And we thought like, well, you know, it'd be really nice if we could. So this was like annotated by a human, obviously. So it'd be really nice if we could like encode this expert knowledge and just automatically annotate all the grids this way to provide the similar information. So we're pretty close to being done with this and having a tool that, you know, you could submit a grid and it will return results on the different areas that these 4 different error patterns occur. The other thing that we're looking at is to look at build log errors in the prow logs and classify it by type. So this is a project we worked on with a master's student, and he did some kind of NLP text-based analysis of the build logs to identify different to identify the difference between test failures and infrastructure failures. And again, this is another project that's getting pretty close to complete so that we can start to actually implement it in a way that as soon as a job completes, it could be tagged as one of these 2 types of failures. We're also looking at recommending early stopping for some tests. So say some test is running on and on, taking up resources, but the likelihood that they are going to fail becomes greater than 90% or whatever threshold we determine. Maybe it's worth stopping it early. We're also looking at predictive test selection. So again, this is a problem around, you know, it's expensive to run tests. And in many cases, all tests probably don't need to be run. So if we can suggest like a subset of tests that are most likely to fail based on like some features of the PR, maybe we could reduce the number of tests we actually need to run and lower our overall resource limit. And yeah, as I mentioned, a number of other there's a number of other ML tools that we're looking at that we kind of have in our backlog. And if anyone here has ideas or suggestions for additional, I'd very much appreciate the input. Cool. So now I can give you all a quick demo of some of this. Does anybody have any questions or anything before I move on?
I have one, but I'm going to save it for the discussion afterwards.
Okay, great. Cool, yeah. So, and just to be clear, that's like a rather high level overview of the project. So yeah, so let me give you a demo. So I hope it was clear. Like there's a number of things happening here. So walking through every single piece of the project, I won't do, but I'll show you some like the critical pieces that I think are most important for how we're managing this project and moving it forward. Cool. So again, the first thing I'll show you is the Operate First website. So this is where this is like the landing page or the place where most of the content, where people should interact with the content. We have ways to get started, and this is really about how to log on to the OpenShift cluster, deploy the OCP CI analysis latest image, which has all of the like reproducible notebooks and content needed to interact with it. And I'll show you all of that in a moment. We also provide, again, documentation for how to contribute. I mentioned earlier the KPI metrics, right? This is like an ongoing thing that can be added to. So as more metrics or key performance indicators need to be collected, we can do that. And we have like a template notebook to help people contribute more easily. And there's also ML requests, like what I just talked about. If there's some new way of analyzing the data that somebody's interested in, they can submit issues that way. And we also have the content. So for all of the data sources that I discussed and all of the machine learning topics that we're currently working on, we have links to interact with all of these different things. So if you want to watch an in-depth YouTube video of me going through the test grid data, you can do that. If you're interested in like the GitHub stuff, you can actually go here and it renders the notebook that we worked on. And this notebook, again, has the details of what exactly is this data, how do we go about collecting it, explaining what are the fields, what is contained in this data, and provides an example of a quick like visualization and analysis of it. So the idea being that if I want to do something new with GitHub data or something, I can start here, and this basically gets me 99% of the way, and I can just, well, this is a static HTML page, but the actual notebook would be able to be something that you could contribute to. Cool. So yeah, so let's say, again, this is great, this is interesting to me, but I actually want to interact with some of this stuff. How would I actually go about doing that? So I already spawned this because it takes a couple of minutes. So I don't want you guys to wait, but I have the OCP CI analysis project from today. It exists in my Zero cluster mass open cloud. I'm able to go to notebooks. We see that we have divided it between data sources and then failure type classification. And we will have additional directories for the different like sub machine learning tasks. But we can go to test grid and metrics, and we can see all of the kind of metric notebooks that were developed by our team. So let's say, for example, I'm interested in adding an additional metric to this work for whatever reason. I can actually just open the metric template notebook, which describes in detail all of the conventions that are required to have it run both as like a usable interactive data science notebook, as well as an automated notebook that's like part of the pipeline. So it tells you all these things you have to do, these conventions around in automation. It also includes all of the kind of helper functions that one would need to just really easily contribute to our data pipeline, and then provides an example of how you actually would do some calculations. I think this one is on counting the number of flakes in the test grid data set, doing some basic visualizations, and then pushing the code to Ceph. So you could copy this notebook and you can copy this notebook, add a metric, and that would be good. But that actually wouldn't get you anywhere. That wouldn't actually get data to Ceph. So the other part of this that's really useful is actually the pipeline file. So this is the Elira extension that we're able to use. And what this is doing is essentially allowing us to drag and drop the notebooks that we've written based on these conventions that we've defined. And then we can, let's say, I just want to add metric template, and I know that it's dependent on this. I can just draw this thing. And what it's doing behind the scenes is creating this like YAML file for us, essentially, this pipeline file that can be consumed by KF pipeline. So I can click run, and this will move us over to, the Kubeflow pipelines, where this was run a little bit earlier. And we can see that each notebook generated its own pod and did what it was supposed to do and pushed data up to Ceph. We can then go back here, and we have a notebook that basically validates that data was in fact pushed, and we can confirm that everything worked correctly. So yeah, so that's kind of the workflow for the metric side of things. I will also show, so we have these metrics and they're being stored. What do we actually do with them, right? So we want to visualize KPIs for users. I'll show you all this. It's still like a PR in review, but the idea is that we have these KPIs that we're actually now able to pull them from Ceph and create visualizations, either in something like Superset or a notebook. And we can say, okay, over the last so many months, the build pass rate is changing. or going down. So for all of the different KPIs that we're collecting, we're actually able to like monitor their behavior, which again is like key to informing whether or not the tools that we're developing are actually useful. So I won't spend too much time here on this one, as it still needs some work, but just to give you guys an idea of like what the kind of end output for this stage of it is. And then again, the machine learning bits are a slightly more independent, but they will also exist as these pipelines, using KF pipeline to do things like take in a test grid like this, and we'll be outputting like a report that tells you which region on these graphs exhibit these different types of errors. Cool. So yeah, so that was pretty much all I wanted to share. I know that was like kind of fast, but again, happy to answer any questions or go into any more details now. So thank you.